Philipp Daniel Schaad.
It was my game plan to speak English today, and I stick to it because, first of all, I think it's an international conference. Second of all, I get a mental split if I look at my slides in English and I have to speak German, so bear with me. I would like to start on a personal note. I am originally from Wiesbaden, which is very close to here. I grew up with aircraft overflying my childhood home every day. Noisy aircraft back in the 1980s, DC-9s, BAC-111s, the occasional 707. And it eventually inspired me to become an aeronautical engineer. So sometimes, in very rare cases, there's a positive effect to aircraft noise. My name is Daniel Schaad. I am the head of instrument flight procedure design for the Austrian air navigation service provider Austro in Vienna. And what I would like to talk about today is PBN-based noise abatement using RNP-AR procedures for noise abatement. We have heard a lot about the RNP-AR type of approach, and I would like to go a little bit into the history of our Austrian history of RNP-AR approaches. Austria is a very mountainous country, and we were forced from the beginning to use this technique of very precise navigation to circumnavigate mountains. So Austria started implementing RNP-AR procedures as early as 2005. We're very proud of that. I'm proud to work for an NSP that has this pioneering role in PBN operations. As a matter of fact, back then, there wasn't even the term performance-based navigation. There wasn't even the term RNP-AR. There wasn't even guidance material from Icana to design those procedures. What we did back then, and when I say we, that's a collective we, that's not a personal we, because I wasn't even with the company back then, so I'm not praising myself, it's the colleagues I'm praising. They went over to the United States and looked at TERPS criteria, which is the American equivalent of PANSOPS, and they designed according to TERPS. So in 2005, the first RNP-AR procedure type approach was implemented in Innsbruck. It was a big success, and we are proud to say that Innsbruck is one of the big three, or the first three airports in the world, together with Juneau in Alaska and Queenstown in New Zealand, to have an RNP-AR approach from the early days on. So we always had a close connection to RNP-AR. And I have to admit, in the beginning, we smiled when we heard about the use of RNP-AR for noise abatement. We said, well, if there's no mountain, why do you use such a high-end type of approach? But we see the benefits today, and this is what I would like to talk about now. I'm glad that Frank Nagel talked about the RF leg, because that would have taken another 15 minutes for me to explain. Thank you very much for that. We should always work together on things like that. And so you know what an RF leg is. Once you use an RF leg inside the final approach segment of an approach, or in the missed approach segment, you have to make that an AR approach. AR stands for authorization required, and it means that the operator needs a specific authorization for this individual kind of approach, location specific, and this is important. So you cannot have an overarching AR approval for all AR procedures in the world, but it has to be an AR approval for Vienna, for Innsbruck, for Frankfurt, if you have an AR approach, and so on. So it is a fairly high demand for the operator. You have to train your crew, your aircraft have to equip, which is not the biggest issue anymore today. But the crew training is costly. You have to apply for the AR approval both at your local CAA and the ANSP of the state where the AR procedure exists. So there's a bit of paperwork and a bit of work included, but it oftentimes pays off. And I have to say, the motivation for AR procedures in places like Innsbruck is clearly accessibility, getting into the airport in bad weather. That's not the point here. Here we use it for a noise reduction. This is what we're used to, using RNP-AR to avoid solid rock, so not flying into mountains. It's very beautiful in Innsbruck. Come and see, and if you land there, you can be quite sure that in many cases you fly an RNP-AR approach. And that's the only option there. There is no ILS. ILS wouldn't be feasible because of the curved shape of the valley. So this is Vienna, and I would like to talk about Vienna today. Vienna isn't very mountainous. It's a fairly flat environment. and a fairly densely populated city. As a matter of fact, 1.7 million people live there, so many more than in Frankfurt, although I have to admit the Rhine-Main area, of course, is bigger when you count all the cities and places together. So 1.7 million, and the airport is fairly close to the city, as you can see on this map. So for us, the incentive was to reduce the footprint, the noise footprint, by simply reducing the overflight area for an approach to Vienna Airport. And we looked at one specific runway, which is runway 16. And this is the airport layout. So coming from the northwest, that would be the approach, where in conventional operations we use RNAV1 transitions, which are a connecting link between the endpoint of a star, of an arrival procedure, to the final approach fix of an ILS. So that's what you usually fly, similar to places like Frankfurt and other areas or other airports in Germany or Switzerland. So you fly an RNAV transition, which gives the controller and the pilot a fair amount of predictability, how many track miles there are. So that's fairly good for continuous descent operations, and it finally leads into an ILS. But you see, you fly a downwind, and if you have an ILS starting at 14 miles prior to touchdown, you have to fly those 14 miles in the opposite direction first, and you affect a large area. Plus you use a lot of fuel and a lot of CO2 emissions in order to fly those track miles. And this was always a matter of debate, how long those transitions should be, because for some they were too short, for some they were too long, because for fuel planning you have to include them, so you have to carry more fuel if you have long transitions. So it is always a critical issue. Usually they are used by the controllers as a tactical means to funnel in the traffic from all directions and actually give shortcuts on these transitions, but still the area of exposure of noise is fairly large. Now look at this. This is our ILS to runway 16, the conventional one, and the final approach fix is at 13.8 nautical miles to touchdown. So that's a fairly long straight segment where you cannot touch the aircraft anymore, where you are bound to the localizer track, and if people live underneath, they will get every aircraft over their house. Now, this is the RNP-AR approach that we designed to runway 16. And you see we have many options there. We have 3 entries from the northwest. We have 2 entries from the southeast. And if you look at the southeast entry in particular, it's a very short approach with a very short final. And that's where I have better numbers to offer than my colleague Frank, but only because we use a different technique, which also puts a higher burden on the operator. We can roll out onto a straight final at 2.3 nautical miles, which is really close to the runway. But this only works because it's a full AR procedure, making use of this high standard of certification, both on flight crew, equipment, and also for ATC. It is a different working method. But of course, you limit the number of users by a high-end technology like this, rather than RNP to ILS or RNP to XLS, as you may call it, where if you keep the RF legs outside the final approach segment, you can make it available to everybody who flies RF legs and doesn't have to apply for an AR approval. So look at this, 2.3 or 2.5, depending on the type of approach. And we published that in an AIC, Aeronautical Information Circular. So the AIC tells you this is a somewhat temporary procedure because we admit that it's still in a development stage, in an experimental stage. And if you see a procedure published in the AIC, you know it's not the final version. It will probably change, and it's probably there to be tested. So our goal was to test 2 things. First of all, the acceptance, the flyability, and so on, but also to do some noise measurements, which I will not present today because they were not very, let's say, conclusive. Because for us the question was interesting if the noise propagation underneath the curved flight path was very different from a straight segment. The results were inconclusive, but that was not the focus of our initiative here. The focus was really to reduce the exposure area by reducing these long finals, the long downwinds, the long transitions, and by having very short entries. And this is clearly a win-win situation because we could circumnavigate the critical noise areas. And we could at the same time reduce track miles, which is the big selling point for airlines, because they, admittedly, if they don't come from the area, they are not so concerned about the noise issues of a local community. They are more concerned about their fuel bill. And if you can accommodate both at the same time, that's really a good selling point. Otherwise, you may convince your home carrier because he has a special relationship to the local community, but you may not convince other users. Talking about the precision of navigation, it's interesting because we talked about how precisely aircraft navigate today. And that poses problems in two areas. One is if you look at opposite tracks in the en route segment, which is not so interesting for our conference today. In the early days when you navigated on airways based on VORs, you could be sure that even if there was a wrong flight level selected and aircraft were head on, there was still a fairly low probability they would hit because the, let's say the distribution was fairly high, even on one airway. Nowadays, they fly right on the line. So if you have a false flight level selected, which will not happen because you have ATC looking out for you, but if you look at remote continental areas or oceanic areas, in case of opposite traffic on the wrong flight level, you could be sure they would be right on. Precision causes problems suddenly. The probability of collision increases in certain scenarios. And for that, in the en route segment, there are techniques like SLOP, which sounds a bit strange, but it means strategic lateral offset procedure. So you have parallel tracks in order to avoid or in order to reduce the probability of a collision. But also for noise. Suddenly you have situations where you don't want them to fly on the line, because you say if they fly on the line and you have people living underneath, as I said, each and every aircraft will be on that line, and if you have a house underneath, it will be affected very heavily. So in some cases you may want an even spread, you want some fairness in a natural distribution of traffic. The old days we had that because of the navigation techniques, which were not as precise. But sometimes the opposite is the case, and you want exactly the precise flight path to landing, because you know where you don't want to be and you know where you can be. So you have a chance to circumnavigate. We saw the segmented approach here in Frankfurt yesterday, which is a similar initiative. And this was our idea here, to say, okay, we identify in a mediation process with our local communities, with our neighbors, where it would be the optimum flight path for landing. And we try to make use of these RF flags really close to landing, really close as part of the final approach segment, to accommodate their needs and to reduce the noise footprint. This is just the charting. You see the two types of approaches, or the two entry types. This is the coding table where you see that we use RF flags if you look closely, but it's not so interesting. And this is the feedback of one airline which comes to Vienna with fairly heavy equipment. They now fly the A380 into Vienna, which we are very proud of course. And they just sent a letter saying, this is great, we love these letters. Normally we get letters where we have people complaining, but if you get a letter like this, you're happy, of course. And they said 100 to 300 kilograms per flight. They come twice a day, and that was with a Boeing 777-300. So it might have changed to the better with the A380. They use the A380 for this approach as well. Same for the emission saving, or even higher. They were happy, and they were very quick in saying, approved for line service, or ready for line use, acceptable, acceptable. We love sheets like that, that's why I'm showing it here. So they were really quick in saying, we want this type of approach everywhere. Please give it to us in all, for all runway directions, which is more complicated than it sounds, because it requires the mediation process that I have mentioned. But still, seeing the operator being enthusiastic for something that mainly benefits our local communities was a great win-win scenario, which we're very happy about. Procedure handling is an issue that doesn't only affect the flight crews, but also the air traffic control operators. I'm working for an ANSP, so I have to take that into account as well. The controllers said they are fine with the procedure, they like it. Initially, of course, they were extra careful because it was a completely new type of behavior of these aircraft in the terminal area. But they said right from the start, with speed instructions on these procedures, they can even imagine accommodating various RNP AR entries at the same time, which hasn't happened yet, but in theory, they would be able to do that. They were a bit cautious about using it as what we call a zip block concept, where you have ILS landings and at the same time RNP AR entries which have to be funneled into the approach sequence. They said this would still be a little difficult, but I just heard from my colleague yesterday that they start doing that actually. They start feeling comfortable about it. I see a thumbs up back there. So this is a mind change. This is a change in the mindset. This is a new approach which they have to feel comfortable with, and they start doing that. It's a learning curve for all of us, for all people like the procedure designers, the flight crews, the ATC operators, and so on. They said using it in-trail, for in-trail spacing would be basically the same for them like on an ILS. So if you have 2 aircraft on an RNP AR, same track, they could reduce to 3 miles or even 2.5 miles in-trail, which is great. And this is actually the direction that ICAO is going. They say they have concepts that the Americans already pursue, which are called established on RNP, which basically considers an aircraft on an RNP AR track to be established, just like an aircraft is established today when it has reached the localizer and is tracking the localizer. So this is really good if you find analogies in handling this kind of traffic to today's way of working. Okay, and the procedure has clearly been flown as a track mile saver as well by the home carrier. They were pretty enthusiastic about it as well. But of course, there's always the burden of certification for AR. So they had this interim solution where they said we use it as a visual procedure in low traffic. We request a visual approach, but fly this procedure. It's in our database. So we test it. We see how flyable it is and how the aircraft behaves and how we feel in the cockpit. So that was a good start. You know, never start too quickly, give people time to accommodate and to feel comfortable with it. And as I said, the noise exposure footprint is really reduced by this short final 2.3, around 3 nautical miles in the first approach, and now even 2.3 in a second revision, rather than the 14 nautical miles for the classic ILS. The airlines were very happy with it, as I showed you. They had some concerns about speed limitations. That's an issue that we are forced to consider when we design RNP AR procedures, because these RF legs that we talked about sometimes require speed limitations. That's part of the ICAO standards that we have to follow. Doc 9905 is our reference there. So sometimes we cannot avoid that. If you have a certain radius for an RF leg, you need to limit the speed. And the airlines sometimes don't like that because they have to change their flap setting and flap speed schedule and have to put out the flaps a little early, which of course burns some extra fuel and also creates some extra noise. But that's a trade-off. You have to find an optimum there. They wanted to go up to 230 and 190 knots at 2 waypoints where we are a little lower, but they said, okay, if it can't be changed, we have to live with that. Controllers have one issue. Controllers love to be in control. I don't know how many air traffic controllers there are, and they are very special kind of people. I really have my great respect, and I see my colleague laughing. I will get a beating later on, I know. But anyways, they like to be in control. They like to vector aircraft around and just feel like they fly all of them. But that's just not possible with an RNP AR approach. You are not allowed to take an aircraft once it's established on an RNP, even before the final straight segment, to take the aircraft off that approach. It's like an encapsulated flight phase, and of course that takes flexibility away from the controller. You can always issue a missed approach instruction, of course, but that means that the aircraft has to go around. But apart from that, there's no touching, no vectoring, and but that's a mind change which also reaches our controllers with time. And they have had this change in philosophy already with the introduction of our RNAV1 transitions, because in the early days, the connection between a star, an arrival route, and the ILS was vectoring. Nowadays, it's connected by these RNAV1 transitions, which I showed you. So that already was a kind of a hands-off approach for the controller. So the mindset is there. But this is an even more stringent version of non-vectoring, of a non-vectoring environment. And again, the AR approval burden for the airlines, which I don't think is a very big burden. Once they see the benefits, they're ready to do it. There were some initiatives at ICAO level where airlines said, give us an overarching one-size-fits-all AR approval. worldwide, which we're clearly against, because especially in places like Innsbruck, where it's terrain critical, we want the operator to be familiarized with the local conditions, and that's part of the AR certification, and you cannot just have a one-size-fits-all approval, so you have to deal with each and every location specifically. I could imagine that one day in the future we differentiate between these let's say terrain and obstacle critical AR procedures and those that are only used for noise abatement, and say those are for free, those are with an easy application, and maybe a one size fits all where you have one AR approval for worldwide operations of that kind, and all the others you have to apply for individually. Maybe that's a solution. That would be my personal solution if I was Mr. ICAO. And this is the outlook for the future. Runway 16 already has now an improved version for the AR, which was like an iterative process with our communities. We said, does it fit your needs? What is your experience? And then we altered the approach a little bit within the scope of what we can do from procedure design criteria. And here is my final result of 2.3 nautical miles, which we are really proud of. A future RNP AR to runway 29 is also planned, which is our main landing runway at night. There is a clear runway distribution scheme also for noise abatement, and this is the night runway. And we are rolling out RF legs in all domains. I heard a question yesterday about using G-bus for departures, and I found that was a very interesting and intelligent question, because we often talk about all these navigation techniques on the approach side, but many of them can be used for departures as well, and the RF leg is one of them. And ICAO now gives us the opportunity to use RF legs even without an AR approval for departures. So suddenly you can constrain traffic very close to the airport on curved tracks, which is really helpful, and which we are planning to use in Vienna and at other locations as well. And the previous experience with RNP gives us a good start, a head start on that. As I said, we were forced to do it because of our mountains, and we're happy to roll it out into the area of noise abatement. And now I want you to finish with me my presentation by picturing an Airbus A380 a couple of 100 feet high, rolling out at 2.3 nautical miles prior to touchdown over an unpopulated area. Isn't that just beautiful? Thank you very much.
Ja, herzlichen Dank, Herr Dr. Schaad, für den Vortrag.
Thank you very much, Dr. Schaad, for your presentation. Questions?
Da hinten haben wir eine Frage.
Thank you very much for your excellent presentation. Just a short question. You were talking about fairness in your presentation. Would you say that there is a difference between fairness and justice? And how would you try to define environmental justice and the way you try to deal with that program, with that issue? Thanks.
Very difficult question, very philosophical question. Let me reduce it to the issue of navigation accuracy. I just think that if you have to overfly a certain area because it's just a necessity out of the resulting out of the airport location, you want to distribute the burden evenly. And if you have a natural distribution shown by a Gaussian curve that you have around a curved track, why not let it be and let it exist like that rather than constraining traffic to a single track? And it is more or less a single track if we fly on RNP criteria, where the guy living underneath has all the burden. That's all I meant. I don't know if that's justice or if that's fairness. To me, that's a bit of fairness, because otherwise you get discussions on whose house it will be that will be most affected, and I think that's not a fair deal. But sometimes, as I said, if you have place in between, you rather go in between with a very narrow and precise navigation criteria. Ich kann auch auf Deutsch an. Ich weiß nicht, ob das die Kollegin in der Box wird, aber wenn
I can also answer in German if there is a German question.
Okay, noch eine Frage?
Any other question?
Nein?
No.
Wunderbar, danke.
Wonderful.
Danke nochmal auch
I
für
would
die
like to thank you
exzellente
very much
Einhaltung der
also
Zeit.
for excellently